Function transformations are like editing a photo. You can shift it, stretch it, flip it upside down, or resize it, but the subject stays the same. Think of the function as your original selfie, and the transformations as your filter options. A vertical stretch is the tall and confident filter, and the vertical flip will turn the selfie upside down. Shifts are the easiest transformations. Vertical changes affect the output. Horizontal shifts feel counterintuitive. Minus means right, plus means left. But if you think about it, sometimes adding can send you backward, like adding to your student loan. This shows the original parabola and its shifted version. Moved 2 units right and 3 units up. Same parabola, different address. Maybe the rent downtown got too expensive. Vertical stretch and shrink are like the math version of those wacky funhouse mirrors. When the graph is vertically stretched, it looks tall and narrow, like it just stepped into the skinny mirror at the carnival. When it's vertically shrunk, it's short and squished, like it ran into the fat mirror. But in both cases, the x values stay where they are. The graph isn't moving left or right, just getting distorted in height. Horizontal stretches work in reverse. The bigger the number inside, the more it squeezes the graph horizontally. To help you memorize this, imagine the graph is like pizza dough. What happens if you stretch it horizontally? It gets squished vertically, and vice versa. So if you prefer thin crust parabolas, apply a bit more horizontal stretch. Here you see that bouncy pizza dough. Pull it wide and it gets thinner. Push it in and it puffs up. Just like life, stretch too far in one direction and something else is bound to collapse. Reflections are like image flips. A vertical flip turns your selfie upside down. A horizontal flip creates a mirror image. And if your selfie looks exactly the same after a horizontal flip, don't celebrate. Your facial symmetry is uncanny, not in the influencer way, but in the you might be the villain in Ex Machina kind of way. Combining transformations is like following a complicated recipe. One wrong step and your function looks like a bad science experiment. Order matters, especially if reflections are involved. Simply follow the order of operations. In 1891, during an emergency chalkboard lecture following a mysterious, possibly terrorist, explosion in the math wing, Parabellow delivered these powerful words to a class too terrified to graph. He spoke of functions surviving vertical stretches, living through unbearable compressions, and even reflections across axes they never expected. They didn't ask for it, he said, but now they're tougher curves than ever before. And from that day on, no student looked at a flipped parabola the same way again.